Hi again. Now, we already know that for nominal data, you will need to use mode. As for ordinal data, you will need to use median as to measure for the central tendency. But for a quantitative data, which is interval and ratio, there's two situations, right? That will actually allow you to use mean or median. So, in a situation where the quantitative data is not skewed, you will use mean to calculate for the central tendency. But in a situation where the data is skewed, you will use median. So the question is now, what does it mean by skewed? Okay, so basically, when a data is not skewed, it is said that the data is in the form of normal distribution. So what does it mean by normal distribution? Now let's look at this. I will just view a graph, an image from a Google search. Okay, this is what it means by normal distribution. So if you can see here, or you can also view figure 1.10. Okay, look at the middle figure, which is symmetric. It has a hill-like shape. In other words, it is known as a bell curve. It starts low, and in the middle it will have the highest, which the peak, and that will go down again. That is what it means by normal distribution. In other words, not skewed. Okay, if your data have this kind of shape, it means that it is not skewed, and you can use mean to find the center point, right? So the question is, why does this shape is known as normal distribution? Why does this kind of shape is said to be normal? Why not like other shape? Why must it be like this? Okay, this is actually just like human and other things, right? We know that what kind of shape that we can say, maybe let's say a car. What kind of shape that we can say that it is a car, a normal car? Or a person, what kind of person that we can say that person is a normal person? We know the characteristic of that thing, that person, that car, or what else? A house, let's say. Other than that, if the characteristic is actually misled from what we know, we will say that it is not normal anymore. So the same goes to data. For a data, if you draw a graph, for this case a histogram, let's say you draw a histogram, okay, like this. If you draw a histogram and it appears that the shape is like this, let me try to make it bigger. It appears that the shape is like this, start from the low point, going up to the peak point in the middle, and then going down again. It is said that it has a normal distribution. Other than this shape, it is not normal. So for this case, this is what it means by not skewed. It is not actually have a accumulation of data toward the left or the right. So this is not skewed, and this is what is meant by skewed. This is negative skewed or left skewed. This is positive skewed or this is left skewed, and this is right skewed. Right? You can also refer to figure 1.10. So mean that when the data is like this, it is skewed. When it is in the middle like this, it is not skewed. But it is not always like that. If it is actually approximate this kind of shape, we can also consider it to be normal. It doesn't have to be perfectly like this. Okay, now why does people say that this kind of shape is considered to be normal in this world? Okay, let's talk about that a little bit. Now, so just imagine that this x-axis here, now let's try to take this x-axis here as the thing that we want to measure, right? So by that, right, means that for normal distribution, right, for a data to be normal, it need to be in this form. In other words, it doesn't matter what kind of data that you have, let it be weight, height, IQ, CGPA, whatever. If you collect enough data, right, if you collect a big amount of data and you try to make a histogram out of it or a bar chart out of it, you will get this kind of shape. That's why for normally a data will be within this kind of shape in this world. Let's take an example. Let's look for CGPA, the thing that is close to us. Okay, for CGPA, let's assume that the X here is the CGPA itself. Let's say we start from 2.0 until the end, which is 4.0. So in the middle, we have around 3.0, 2.8, what else? 3.1, right? That is the value in the middle. So 2.0, 2.5, 2.8, 3.0, 3.2, 3.5, 3.8, and 4.0. Let's imagine it like that. All right. Now, my question is, how many students that you know that have a CGPA within this area, which is 2.0 till maybe less than 2.5? Not that many, I can assure you that. Okay, there is only just a numbers of them. Okay, how about so because of that, we can see that the frequency is low. That's why the graph is low. But as it approached the middle point, which is 2.8, 2.9, 3.0, 3.1, 3.2, 3.3, it become a lot. The number become bigger and bigger and bigger, right? So for as it goes to the middle point, which is 3.0, 3.1, 2.8, 2.9, the bar the bar here become taller. So but then as it move forward to, let's say, 3.3, 3.4, 3.5, the bar become lower again because there are not that many students get that kind of CGPA. And as for 4.0, maybe just 1 or 2. Okay, this so hence the shape become like this. That is actually what is a normal kind of data that we have in CGPA. The same goes for height. How many? Just imagine that this is actually the number of the measure of height in cm. Let's start it with maybe 100 and what will be the minimum numbers of height. So 150, let's say, or 135, 140, maybe 140. So let's, as the x-axis goes up, the cm goes up. So 140, 145, 150, 55, 60, 65, 770, 75, until here 200. Okay, so let's imagine it like that. So let me ask you again, how many number of students that you can see that have actually a height that is 140, 145, 150? Not that many, right? There are that kind of height that we will be able to see, but that is not that many, maybe just a handful of them. Next, as the centimeter goes up, right, we have 155, 160, 165, 170, 175, 180. So at the middle point, 160 until 175, maybe I can assure you that we actually able to find this kind of height easily around us, because there are a lot of them with this kind of height. So the number of the frequency is actually among the highest. And then as the cm goes up, which is 180, 185, 200, how many of them that you can see that have that kind of height, which is almost 200 or 195, 190? Not that many. Maybe there's that kind of height around you, but just maybe 1 or 2. So the bar become low. So to conclude, you start low as it goes in the middle, it become high, and then when it goes higher, it become low again. That is the kind of normal distribution of heights in this world. If you want to talk about weight, it will be like that. If you want to talk about IQ, it will be like that. And there are several other things that it will be like this. So this is the kind of norm for data. For it to be normal, it should be like this. So when the data not like this, maybe it is like this or like this, which is not symmetric, we can say that it is skewed and it is not normal. Alright, so in the next video we will discuss why mean and why median. Okay, why mean when the data is normal and why median when the data is not normal.